Okay, so today's video is focusing on adding and subtracting radical expressions. We'll start with a little review about simplifying because that's important in order for us to be able to add and subtract. So we want to use that list of perfect squares that you should have in your notes from yesterday. If you don't, then we'll just make a list right here at the top, make it nice and easy. So we have 1, 4, 9, 16, 25, 36, 49, 64, and you can keep going from there if you want to, but that's the list that I'm talking about. So in order to simplify, we want to make sure we are dividing the radicand by the biggest perfect square number. So if I look at 512, I need to see what I can divide 512 by. So I'm going to try I'm going to try 64, see what happens. So divide by 64, 8, perfect. But I think that there's another smaller number that goes into there, but I don't know what it's going to be. So if you get a perfect square that works, but maybe it's not the biggest, this is a good example of how we do that. So take the square root of 64, and that gives me 8. So I have 2 times 8, and then square root of 8. 2 times 8 is 16, but also we can keep breaking up 8 into a perfect square. So we can break it up into 4 and 2. And then I take the square root of 4. So I have 2 times 8 times 2, square root 2. I multiply everything together on the outside. I get 2 times 8 is 16. 8 times 2 is 32. So 32 square root 2. So if you take out a perfect square and then you realize you could have taken out a bigger one, you just kind of keep going. You don't have to stop, but you can just keep going. So let's look at the next one. These are the cube roots. So when we look at the list of cubes, you should have that list from last class too. But if not, we'll make another little one. We have 1, 8, 3 cubed is 27. 4 cubed is 64, 5 cubed is 125, and then we can go bigger if we need to, but that gives us a start. But I think that 125 is going to go into 250, so 250 divided by 125, sure enough, that's 2. So we're going to take the cube root of 125, so that's 5. 5 cube root 2, and there we go. Okay, now looking at the last one, we're doing the cube root, and this time we're breaking up negative 40. So negative 8 times 5 gives us negative 40. So cube root of negative 8, if you forget, you can just go over here to your calculator and cube, and then negative 8 as the radicand gives us negative 2. So 3 times negative 2 is cube root 5, x to the 5th. So it gives us negative 6, and then we can pull out 3 x's. So x, and then cube root of 5x squared, because we have 2 left over. So now to get to our steps for adding and subtracting radicals. First thing we need to do is to simplify all radicals. After we simplify them all and get them down to their smallest radicand, we want to identify radicals with the same index and the same radicand. After we identify the same ones, we want to, for common radicals, add and subtract coefficients, keeping the radicand the same. So here, if we look at number 4, these are already simplified as much as possible. So we have a common index. Remember, the index is the little 3 that we see on the outside. So we have the same index and the same radicand. So all I want to do is add and subtract the coefficients. So 3 minus 2 is 1. And then the radicand stays the same. So we don't need to write that one in front. Remember, it's an understood one. So we would just say 3 or cube root of 6. Okay. If we look at number 5, this one we do need to do a little simplifying. The 10 square root 7 is in its simplest form, but we can break down square root of 63. So I think 9 is going to be the biggest one to go into 63. So 63 divided by 9 is 7. And we square root 9. So we get 2 times 3 cube root, or square root 7. And we bring down the 10 radical 7 because we didn't need to change that at all. So we'll do our multiplication. So we have 10 square root 7 plus 6 square root 7. Combine the coefficients on the outside. So 10 plus 6 is 16 square root 7. It's kind of like terms here. Things with the same radicand and index are considered like terms. So one more to simplify. Here, we need to simplify that first one, the square root of 20. So I know that 4 goes into 20. Oops. So we have 4 times 5. Square root of 4 is 2. So we have negative 2 times 2. Square root of 5. We bring down the second term, nothing changed. Do our multiplication, kind of thinking order of operations here. So negative 4 square root 5 minus 2 square root 5. For my coefficients, I'm doing negative 4 minus 2. So since they're both negative, it's getting even more negative. So it would be negative 6 square root 5. Perfect. And then if you're feeling good, go ahead and you can pause the video and then give this a try on the next ones. If not, go ahead and just keep following along. In number 7, we see that these are both already simplified. We have the smallest radicand possible. So we are just combining 4 and 3. So 4 plus 3 is 7. So 7 square root 5. In this one, we can definitely do some breaking down. So let's look at the 45 first. We know from a previous problem that both 9 and 5 go into 45. So we take the square root of 9, so that would be 4 times 3 square root 5. And that gives us a hint. Since we know that these want the same radicand, it's going to be something in 5. So if I do 245 divided by 5, I get 49, which is great. It's a perfect square. So I'm going to take the square root of 49, so that's 3 times 7 plus 5. Do our multiplication first, and then the addition and subtraction. So 4 times 3 is 12 square root 5 plus 21 square root 5 gives us 33 square root 5. Okay, so now in 9, we have 3 different terms, and we want to think about like terms. So which terms are like each other? So I'm going to circle our like terms here since everything's simplified. So negative 2 square root 10 is a like term with this negative square root 10 because they have the same radicand and the same index. So I can only combine those. I can't combine it with the negative 3 cube root 6. So negative 2 minus 2 is negative 4 square root 10 minus 3 cube root 6. And since we can't combine anymore because they're not like terms, then we just leave it there. So it's okay if we end up with 2 separate terms in our final answer, or maybe even 3 separate terms in our final answer, as long as none of them are like terms that can continue being combined. Okay. So just a few more examples on the back. Again, we have a couple terms. So I'm going to go ahead and circle our like terms here. You can circle them on your paper too. We have 2 terms that are square root 7 and 1 that's square root 3. So when I combine the 2 that are square root 7, 2 plus 4 is 6. So we have 6 square root 7 plus 5 square root 3. Beautiful. Okay, now with 11, we definitely need to do some breaking down here. So let's start with 50. Need to look for a perfect square that goes into 50. So 50 divided by 25 would be 2. So I take the square root of 25, which is 5. So negative 3 times 5 square root 2. And then 18 can be broken down also, and I know from the first one that I'm looking for a radicand of 2. So 18 divided by 2 tells me it's going to be 9, which 9 is a perfect square. So square root of 9 is 3, so 3 square root 2. We do the multiplication, so negative 3 times 5 is negative 15. Square root 2 is 3 square root 2. Negative 15 plus 3 would be negative 12 square root 2. Okay. And then for this one, 15, there's no perfect square that goes into 15, so we're going to break down 60. And that kind of gives me a hint again that I know that I want one of the numbers to be 15 because that's the radicand that I need left over. So 60 divided by 15 is 4. So square root of 4 is 2. So I bring down the square root 15. And then minus 6 times 2 times square root 15. So 6 times 2 would be 12. And whenever there's not a number in front of the radicand, we can assume that the coefficient is 1. So here, it's like we're doing 1 minus 12, which is negative 11 square root 15. So 3 easy steps that we want to follow here, kind of all hinging around simplifying. So first, we are going to simplify, then identify and combine like terms. So let's do a little bit of a blast from the past here. A couple lessons ago, we looked at identifying key features. So let me go ahead and pull up our scientific calculator here. And not our scientific, our graphing calculator. So you can go ahead and get this graphed and get an idea of what we're looking at. So here, I'm going to go ahead and graph it. So y equals square root of x minus 2 plus 4. So here's my picture. So I can sketch a little picture on my graph. See that I have this ending point at like 2, 4. It curves up and over. So domain, remember, is looking at x values. So I want to start at the smallest x value and go to the biggest x value. So the smallest x value I see here is 2. And it goes to the right forever number. So 2, infinity. And then range is looking at y values. So the smallest y value I see, or the lowest point, is 4. And from 4, it's all of the values that are above that. Because if I were to continue zooming out, I see that it's getting a little bit taller on that right end every time. So my range would be 4, infinity. And when I look for the x and y intercepts, I'm looking for where it crosses the x and y axis. So looking here, I have nowhere that it crosses the x-axis or the y-axis. So I would actually say none for the x-intercept and none for the y-intercept. Now, talking about our transformations, this 4 on the outside clearly moved it up because the center is normally at 0, 0. So I would say 4 units up. That 2, remember it's opposite kind of what we think on the inside. So instead of going left 2, this is going 2 units right. And the last thing is that 3 in front. And that 3 is telling us a vertical stretch by 3. So we want to keep in mind those graphing things because those aren't going to go away. They're very helpful for us. But now you've learned to add and subtract radicals in addition to simplifying them.